First of all, thank you for being with us. Thanks to Sanjay Saxena ji and Khan sir and Polyconnect team and for giving me this opportunity. When they told me to give a presentation, I don't want to go for a generic presentation or a repeated presentation which everyone gives. Today the buzzword everywhere is AI. May it be a simple mobile mechanism or may it be a Photoshop or anywhere we go, everyone talks about AI. Then I thought that why don't I make an attempt, or rather I would say, why don't I contemplate? Thankfully, I have taken a few inputs from my daughter. She has done her BTech in AI/ML. She works for Caterpillar Incorporation. So let me try my level best to touch the tip of the iceberg, though I'm not good as software engineer, or I can't do much on the coding, decoding part, how it works in plastic industry. She has already briefed about myself, and this is about my company. We are mainly into plastic consulting. Starting with manpower I started, then sourcing and marketing support, slightly diversified into business analysis, then project management to a certain extent, recently diversified into digital marketing. Also, I have a tie-up with a company who does that upskilling training programs. Today, most of the companies, the gap is management and employees. There is always a gap, so we fill up that gap. And our professional services, these are all the professional services. Before I start the presentation, I would like to touch a few inspiring quotations. Let me talk about the innovation, starting from Jack Welch. We know where most of the creativity lies is the innovation, the stuff that drives productivity lies in the minds of those closest to the work. That is, those who are near to the machine, those who are in the forefront, they are very close to the innovation. Next, you take our great scientist Dr. Abdul Kalam, Aerospace, and Dr. C.V. Raman for light scattering, Vikram Sarabhai, Homi Bhabha, then Venkatraman Radhakrishnan, J.C. Bose, Nambi Narayan, Raj Reddy, Saha. These are all motivated really how innovation can be driven, not only in science but also in plastics. Let's see what Elon Musk says. Failure is an option here. If things are not failing, you are not innovating enough. And Steve Jobs said, innovation distinguishes between a leader and a follower. And Bill Gates said, the advance of technology is based on making it fit so that you don't really even notice it, that technology is advancing. So it's a part of everyday life. Creativity is thinking up new things. Innovation is doing new things. And the marketing guru with whom I really get impressed, Peter Drucker, says innovation is the specific instrument of entrepreneurship, the act that endows resources with a new capacity to create wealth. With this positive note, I am pursuing ahead with my presentation. Let's see the industry evolution, how it started, plastic industry, starting from 1960, where we call it as 1.0. That is 1950 to 70 age-old typical direct drive injection molding machines. Then we had this plastic industry 2.0, that is 1980 to 90s. Then further moved on to 3.0, where ERP, robotics have just started, that is in 2000 to 2020 era. Now we are in the 4.0. I am going to touch upon that 4.0 aspects where AI, that is artificial intelligence, machine learning and Internet of Things, how it's going to revolutionize. Again, I am giving a schematic diagram how Industry 4.0 works. May it be additive engineering or simulation, augmented reality, industrial Internet of Things or horizontal verticalization, cyber security, the cloud, big data analytics. Though it looks like a buzzword, all are integrated in the plastic industry. Let me explain in brief in the forthcoming slides. Same industry starting here, 1.2 we have already seen, it is the 17th century, 18th century. Today we are at the cyber physical systems where all our machineries are driven automatic, and these are all the tools that constitutes the Industry 4.0. These are the core technologies. I'll not go in depth of it. I'll just touch the iceberg. there are three kinds of sensors. One is pressure sensor, second is vibration sensor, third is AIML, that is anomaly detection and optimization, which can be integrated into injection, roto, extrusion, that can be fed into IoT, that is Internet of Things in the edge gateway, so that all this data can be fed into cloud or MES or dashboard. Let me explain in the coming slides. Now, what exactly Industry 4.0 means? Industry 4.0, it not just means integration of software into the things. It is a simple term is smart manufacturing. Everyone does the manufacturing. How do we reduce the rejection, improve the productivity? Already there are many QS systems are available, many systems are available. How smart manufacturing can be achieved? That is what we are going to talk about in Industry 4.0. Now, why exactly AAML matters in the plastics? AI and machine learning are crucial for in today's context, because not only because of competition, not only because of getting obsolete things, but also it transfers traditional manufacturing into smart factories. Today, maybe Toyota, maybe Honda or any car manufacturing unity, everyone is going into smart manufacturing. Then why not in plastics? So here the most important aspect today is sustainability and regulations. That is EPR recycled targets, and the opportunity is for sustainability is reducing scrap, energy, downtime, and improving the quality. Now, this AAML can be applied into four major broad categories of plastics. One is injection molding, where we can do the defect detection, cycle optimization, and energy efficiency. Extrusion, we can do the thickness control, process stability, and real-time monitoring. Roto molding, we can already, it has been touched in the previous presentation. One is a temperature profiling, and then the predictive quality control. Recycling industry, sorting, I had a discussion with Dr. Prashant before lunch. Material sorting, and then contamination detection and process optimization. Now, what are the myths? Everyone thinks that once AI comes, automation comes, हम लोगों का नौकरी चला जाएगा, तो मैन पावर सबको खतरा हो जाएगा, यूनियन खड़ा हो जाएगा. Not really. It is still a myth. Why it is a myth? Concern, automation removes the jobs. Not really. In automotive AI, ML, IoT, it is just automating the task, but not the jobs. You need a programmer, you need a performer, you need a person to access the IoT. So it will not take away the job. Second, it reduces the operator need. Not at all. Operators become smart machine operators. So we are elevating the operators. We are not taking away their jobs. Third, data replaces decision making. Not at all. Data is just supports the human management. Ultimately, human resource is the one who decides. Fourth, machines controls everything. Not really. Humans train the machine. Machine does not train by itself. Humans train the machine, monitor and optimize the machine. Last, as I said, sabka naukri chali jayegi. Not really. Loss of employment. Upskilling happens in AI and ML and reallocation of manpower. So, if anyone talks that AI ML will take away job, we can confidently say no, not at all. In plastic industry, we are creating smart manufacturing, so it will create more jobs for human resources. Now, how AI enables innovation in India? One is algorithms to analyze the data from machines to optimize the production. Already Raju, he has already briefed about it. And IoT networks, it gives the real feel of monitoring and control. It is not possible for a owner, for a shift in charge to be present in the factory 24 hours, 24/7. That job IoT does. Next, digital twins. Now, we have all seen one robo working. When two robo work together, that's what we call it as digital twins. That is, we simulate a process, may it be a flash cutting, may it be a taking a component out, or may it be putting an insert. We can deploy the digital twins, which does the multiple jobs of a operator or whomsoever it is. Next, the smart materials and molds. These are embedded with sensors so that they collect environmental and operational data to enable responsive manufacturing. Next, data-driven decision making. As I said, whenever we need a decision to be made, whether this is really a particular shift, this mold we are running, is it really effective? Particular roto molding process, yes, there is a thickness control. That decision making needs a data. That data is fed by this AI/ML. So in India, most of the modernization of manufacturing ecosystems, now it is getting enhanced with sustainability, compliance and regulatory mandatories like EPR. So that goes with AI/ML. Now let's look at the global scenario, how it works. Like if you see the AI in manufacturing, it was approximately $7.9 billion in 25, and smart factory almost 170 billion in 2025. So industrial IoT, again, it is almost 290 billion in 2024. So there is a positive and very proactive, I can say, there is a proactive growth for AI in plastic industries. Next, present Indian market scenario. Okay, we talked about global, how it works in India. I have got the data from the valid and trustworthy sites, marketing research insights. The AI potential, present potential is somewhere around 65K CR, and industrial IoT, it is around 780 CR, and IoT market potential is around 486 CR, and smart manufacturing is somewhere around 1000 crore market. So venturing into this, yes, definitely involves higher capital, higher resources and all, but the market is really growing. Next, let's see what are the key connectivity standards. There are basic parameters like IoT and cloud computing. If we set up some process, if there is some unforeseen circumstances happen, we need not have to worry. All those data is stored in the cloud. Next, open platform communication unified architecture. What it does is machine to machine communication. If we have say 100 machines in a shop floor, it is not possible to communicate from one machine to another. That job does by AI/ML. So that is what we call as open platform communication unified architecture. This two specific softwares, especially Euromap 77 and Euromap 83, has been built on OPC UA to define the interface between injection molding machine and manufacturing execution systems. Again, industry IoT platforms, there are new platforms coming up, like for example, logistics can be integrated with the manufacturing, and third-party applications. Suppose if any third-party molding to be done, that also can be integrated in IoT. Next, we have a standard network protocols. Through computer, we can suppose you are getting job work done through some other vendor or someone, that can be controlled through software. Next is wireless communication, like we have wireless communication, Bluetooth in phone and laptop, that is possible in machinery also, like we have Zigbee, LTE, 5G, enable flexible and scalable connectivity that can be connected to sensors and machine, so that factory environment, sitting in the mobile, you can access it. Now, what is the importance? Again, enabling data acquisition and integration. Next is facilitating real-time monitoring and control. Third is enhancing supply chain integration and driving the data analytics and AI. Now, let me give a brief how injection molding state can be implemented with this AI so that it really works as a smart manufacturing. Okay, high data density per cycle. Say for example, you have so much of data, as Sandeep sir has said in Raju, there are so many data are there. Say for example, clamp force, melt pressure, cavity pressure, screw position. All this data can be fed into that, so that we don't have to search for a manual or anything. Next, common innovations. One is closed loop activity, that is a pressure control, and AI based quality inspection. That is, we don't have to visualize the components. Through software, we can have a closed loop system to control the quality, and remote monitoring. And before any unforeseen circumstance happens and upset happens in the machine, that can be done through predicative maintenance. What is the benefit in injection molding? I'll cite out examples as well. 10 to 30% scrap reduction is there, and 5 to 15% uptime improvement is there. Now, these are all the few examples, specific examples I have given. Hope this is visible. These are the areas where AI has been applied. So the scale for measuring the weight, the dimensional measurement system, and the camera for surface quality inspection. If we depute a person, a QA person for each and every activity, at least we need some 6 to 7 people to do that. But if we depute AI ML system, it does all together in one shot. Next, injection molding innovations. What do we mean by digital twins? This digital twins, actually it optimizes and simulates the molding cycles and reduces the trial and error process. Next, RFID tags can be attached to the components. Suppose if any particular, suppose if there is 30,000 components are done, which goes into the assembly line, any particular part is found to be defective, that can be retrieved through RFID tags. Through manual process, through manual batch process, it would be very difficult for us to track it. Next, what are the innovations happening in India? One is growing and adoption of IoT and AI systems in injection molding plant. Second is many startups. I'll give the examples and case study in the coming slides. AI enhanced system for predictive maintenance and process automation in Indian factories. What are the key use cases? One is process anomaly detection. Second is predictive maintenance. Third is automated visual inspection. Fourth is mold health. When a mold completes, say for example shots, 5 lakh shots or 10 lakh shots, that health monitoring can be done by this AI ML itself. Now I would like to run a small video. Sound please. Sir, sound. Sound. Volume. Particular video में sound. वीडियो करना इसी में हमें आ जाए वीडियो आ जाए एक मिनट चालू होना चाहिए कर सकते
Let's talk about IoT, the Internet of Things. Sensors on machines collect data and send it to the cloud. This means faster problem solving and less downtime. Next up, AI and machine learning. These technologies predict issues before they happen, making your factory more efficient and cutting costs. And don't forget about robotics. Robots are taking over repetitive tasks, freeing up humans for more complex work. Finally, augmented reality. Imagine technicians using AR glasses to get real-time repairs guidance. It's like having a tech guru by your side. Industry 4.0 isn't the future, it's now. Get on board and transform your factory today. Thanks for watching. Don't forget to like and subscribe for insights.
I'm done with the injection. Let me go with the extrusion. Extrusion is enabled with AI, ML, IoT and automation. Here again, IoT sensors monitor parameters like temperature and pressure. Algorithms optimize the settings and predictive issues. Digital twins, they does the testing and refinement, and predicative maintenance does the preventive downtime. It does. I'll just cite a few examples, maybe pipe or profile or anything. This intelligent optimization processing sensor data to identify the patterns, predict defects, and adjust machine parameters. And digital twins create virtual models. Suppose you have any specific profile or specific model to be done, that can be done through digital twins. That is a modeling thing. What are the core components of extrusion? Same, whatever we have seen in injection, same thing is available in extrusion 4.0. These are all the parameters required for implementing this 4.0. Like algorithms analyze the sensor data to maintain extrusion parameters. Then real-time data for IoT melt. Whenever there is a melt temperature monitoring or any process temperature, that is done by IoT. And then digital twins shorten the new grade launches, and integration with additive manufacturing. Say for example, you want to create a new plastic product, new design, that additive manufacturing 3D software can be incorporated with this extruder. Next, innovation India. What all the major innovation happening is, one is rapid adoption in mid to large extrusion shops, and then PLC and SCADA systems upgrade with cloud analytics, then government manufacturing and digitalization initiatives, plus in sensor edge cost that accelerate the plots. Then blockchain and IoT enables the entire supply chain, starting from incoming raw material to outgoing. Entire thing can be monitored by blockchain and IoT. And increasing extrusion lines are equipped with IoT today, with IoT sensors for monitoring waste reduction. Let's see some of the case studies related to extrusion. One is Engel, that Austrian company. They have incorporated this AI technology. They had a problem wherein machines produced a lot of data, but it was not used actively. Then they used the technology of IoT, cloud and security stack to overcome, and so that all those data fed can be used by the operator. That Matrix has given almost more than 80% of the threats. That is for Engel as come out of that security threat. That is, their software cannot be stolen by others. Next is Crossma extrusion. They have exhibited in K-Fair. They had a problem of extrusion lines varying with variable recyclates, need higher throughput and lower energy and simpler operator experience. They use the technology of modern process control, then digital HMI and smart sensors. With that, they could implement a new twin screw systems with 20% energy reduction. Next, future trends. What are the future trends ahead in 4.0? One is North America and APAC. They have high penetration of digital twins, and larger OEMs and tier 1 suppliers are implementing this AI ML in that. And development of new sustainable, especially in recycling, they are implementing this AI ML. Next, this roto molding, how we can implement this AI ML. Historically, it is a low automation process. Roto molding is well known, but it shows a rising interest in oven and rotation control automation, and also fill weight monitoring, robotized demold and finishing, and digital process logging. The key use cases can be, one is oven profiling and energy optimization using IoT ML. Next, fill weight control and inline gravimetric feeders. Next, automated finishing and inspection using machine vision. Then predicative maintenance, as we do in injection extrusion. In roto molding also it's possible. A few innovations, like, so for example, startups with eco-friendly roto molding materials with closed loop recycling technologies, they have implemented. In Europe it has been done, India it is yet to be done. And the machine learning predicts the optimum heating cooling cycle, and it facilitates 10 to 20% energy savings for tanks, crates and boats application. The most important thing is, it's a huge retrofit opportunity in the Indian SME sector. Next, roto molding innovation may be a rotoline variants like shuttle, carousel, rock and roll, spear, oven. They have shown some. challenges.
Welcome to Roto Line. Today I want to show you the Roto Line shuttle machine. Shuttle machines are capable to produce any part in polyethylene. The machine is divided in three main parts, a central oven and two carts. It's this setup and an independent recipe for each car that allows the efficiency in production of many parts. The shuttle machine is the best option to manufacture parts of different shapes. The shuttle machine has a cylindrical oven to guarantee an efficient airflow throughout the process. Also, the oven structure is sealed to prevent heat loss, resulting in a gas consumption economy. The standard machine is equipped with straight arms and can be replaced for an offset L or offset C. The arm speed can be programmed on the recipe screen. Also, you can program temperature, oven time, and reverse rotation. The machine has cooling fans on each station. The air assist cooling developed by Roto Line has a continuous water and airflow, preventing water accumulation in front of the fans, speeding up the cooling process. The equipment goes through a strict manufacturing, quality, and testing control. The installation is always supervised by a Roto Line technician. Fast and efficient technical assistance in three languages: English, Portuguese, and Spanish. Panel connections are made with quick disconnect plugs, reducing machine installation time. To facilitate the operator's routine, the interface includes a computer with a navigation system that is easy to operate using a mouse and keyboard. The software can display many informations as fault log, diagnosis, product information, PLC inputs and outputs, among others. Now you know a little bit more about the shuttle rotational molding machine. Come and visit us. Welcome to Roto Line. Today I want to show.
Next, roto molding case study. Let's see a specific case study where development of specialized fuel tank for a ground-keeping equipment manufacturer. Heat flow, there was an issue in heat flow which could be focused on the appropriate area for improved material dispersion and create improved threading. So, and also there was an issue in the direct heat flow which are not allowed in to change a wall thickness. So after implementing this, controlled heat focus allowed for unique geometric forming, which was not possible in the conventional rotomolding process. Now, a few innovations which we have seen is one of the smart sensors, Internet of Things, allowing operators to monitor performance remotely, and CNC machine enabled molds that enables the creation of more complex designs with tight tolerances and high dimensional precisions. Now, future trends. What are the future trends? One is thermal profiling with IoT, digital twin process simulation, automated part handling, and integration with Industry 4.0 platforms for process optimization, and digital twins can be deployed in that rotomolding cycle for simulation and waste minimization. Now, 2025. When we talk about this recycling industry, as I said, one is sorting the incoming and outgoing material, that is one process. Another is rapid adoption of AI and vision-based sorting, robotics for pick and place, optical NIR and higher spectral polymer ID, and conveyor analytics. These are all the new technologies implemented in recycling industries in Europe. I'll run a small video, please. Next, recycling and circular economy, it's already well known to us. EPR and FMCG demand accelerate the adoption for us. So there is a need for applying AI and ML, that is edge AI system into recycling. And carbon reporting encourages the energy efficient process controls and product stewardship and traceability, that is the digital passports of right from the scrap to the end product recycled, and that really facilitates the circular economy. Future trends in 4.0 in recycling, you see the waste management may be that is going to revolutionize, scaling up biodepolymerization and chemical recycling as mentioned by CPET director. There AI finds a vital role in it. Impact of ROI, that is impact and return on return on investment for plastic industry 4.0. We have just an analysis, AI versus plastic industry 4.0. So AI manufacturing here, if you just see, and estimated plastic industry growth here. So there is a phenomenal increase in this domain. Blue one you can see. So starting from 25 to 30, the growth trajectory is very fast. So it will enable scrap reduction to 10 to 30% in terms of material savings, and energy savings between 5 to 15%, and cycle time optimization as well, and uptime gains, not only downtime, uptime gains between 5 to 20%. These are all the major application segments where AI/ML finds a vital role. These are all some of the live examples of mold change, especially mold temperature and clamp pressure, where AI/ML finds a vital role. How it works? How it works? One is generative AI in product and mold design. The trend is it will give a optimal mold designs based on the mechanical strength and weight reduction. Next is impact will be faster design to market. It will give it will reduce the time. Instead of doing a prototype and then conceiving a full-fledged mold, it will reduce the time. And moving from time-based maintenance to event-based predicative maintenance that can be done with AI/ML. Now, some of the cross-cutting innovations which applies to all process in AI is, one is edge-enabled PLC gateway, second is standardized sensor suite, third is cloud platform, fourth is MES integration, fifth is analytics dashboard and mobile alerts. All are applicable in all kinds of injection molding process or recycling or roto molding, any process. India case studies. Let us see some of the case studies. Reliance Industries and Adani, they have implemented this AI/ML with advanced polymer manufacturing capacities, having implemented digital manufacturing, and they increase the efficiency as well as sustainability. Second is a Rosti Group, it is near Chennai. They have implemented this leveraging AI enhanced process monitoring system. Third one is Hyderabad-based company called Banyan Nation. They implemented AI sorting. Fifth is Izumi India, it's a well-known company. They implemented smart injection molding solutions for injection molders, Indian molders. Next is Recycle. This is again Gurgaon-based company. They introduced a digital platform for plastic waste traceability and transparency. Next, Schneider Electric Bangalore and Hyderabad. They have integrated energy-saving IoT and automated solution, especially for switch gears. Then Siemens in Kalwa, Mumbai. They transferred digital twin technology and IoT to increase their productivity and flexibility. Piramal Glass, even glass company, they have implemented AI. And Clarivis, they started up, it's a small startup company which has provided IoT sensor-based monitoring system. Chisel, it is again a European company, produced a B2B cloud platform for supporting SMEs. What are the advantages? As we have already seen, one is productivity, second is rejection control, third is quality systems, fourth is supply chain, fifth is R&D efficiency, and last but not the least is operational excellence. These are all the KPIs we can track. Having implemented AI/ML, we can track the original equipment efficiency, scrap rate, energy and part, and unplanned downtime. So the efficiency always goes up, rest all comes down. Now, what are the challenges? Key challenges. There are 4 main challenges. One is ensuring the quality of the data. Data has to be rechecked. Second, cultural resistance. As I said, AI आने के बाद हमारा नौकरी चली जाएगी. तो वो that attitude, cultural resistance has to be there. We need to tackle that. Next, investment roadblocks. Most of the SMEs in India, almost 70% of the SMEs, they are not in a position to invest on AI ML because investment, it calls for high investment. Next is improper training. We need a proper workforce to be upskilled to get this training. What are the future trends? One is connected machines. As I explained in the second slide, Euromap and OPC UA, they are having open communication standards which enables various kinds of technologies. Second is smart cells, that is self-contained internet connected production units. Third is greater use of digital twins and physics informed ML. Future global market scenario is, one is autonomous production systems with nearly zero downtime. Second is AI enabled R&D accelerating material innovation, that is bio-based and recycled polymers. Then supply chain integration. Future Indian market scenario, as I said, AI/ML will facilitate predicative maintenance and then smart factories, wider use of robotics and digital twins for faster new product development, and expected CAGR will be around 18 to 20%. This market is expected to reach between 60 to 80k crore by 2030. Conclusion is, the convergence of AI and automation with Industry 4.0 will definitely transform the industry with customization, quality, reducing waste, and enhance the competitiveness in the global market. So join us in the revolution of Indian plastic industry 4.0 with innovation by engaging us, starting ideas, and emerging with new technologies. Let's be a part of ecosystem with innovation and work together and implement in the coming years. Jai Hind. Thank you.
Thank you, sir. Thank you for taking us into the world of Industry 4.0 with such clarity and futuristic thinking. Your session has opened doors to limitless technological possibilities. May I now request Mr. Sanjay to felicitate Mr. Suresh.